In my previous video, I discussed about the recursion technique. In this video, I will show you the indirect recursion. Look, recursion can be indirect also. If a function calls another function which calls its caller function from within its body, it is known as indirect recursion. Look at the example below. There are two functions, a and b, written as defa and defb. From within the body of the a function, b is called, and from within the body of the b function, a is called. That's mean when we are calling b function from within a function, the control goes over here. Now from within the b function, we are calling the a function. That's mean the control will again go back to the previous function, that is a. Look at the flow lines. The control is switching in between these two functions, and this will never end. Alternatively, you can say that these two functions stuck into a loop, or rather an infinite loop. So again, I am repeating the definition. If a function calls another function which call its caller function from within its body, it is known as indirect recursion. So when a is calling b, b is again now calling its caller function, that is a. Let me show you an example by writing program. Let us take this exercise. Check whether a number is even or odd using indirect recursion. First of all, let me write the program for you. I will write two functions. First one will be look like this, def. It will check whether a number is even or not. So I've written is underscore even. It will take a single parameter x, and within this function, if x equal to 0, it will return true, else it will return and call is odd function with the decremented value of x, decremented by 1. Now, so the next function will be is odd. So this function will check whether a number is odd or not. So this function also take a single parameter x, and from within this function we will return not is even. We know that odd is not even, so I have written not is even, and within bracket it will pass the value of x. Now from within the main code, let me print and call the say is odd function, and the parameters say 3. So here we will check whether this 3 is odd or not. We all know that 3 is odd, so this function will return true. And if I write any even number over here, then it will return false. First of all, let me run the program. Look at the output. This 3 is odd, so it returns true. Now if I write 4 over here, now it will return false. So look at the output at the right hand side, it is false. Now if I write is even in place of is odd within the main code, if the parameter remains same, that is 4, now run the program, it will return true because 4 is even. Now if I write 3 over here in place of 4, look at the output, it will return false. So we can call any one of these above two function from the main code and check whether a given number is even or odd. First of all, I will explain this scenario. Also, I will show you the state diagram, how it is working. And I think it is very clear to you why it is called an indirect recursion, because from within is even function we are calling is odd function, and from within is odd function we are calling is even function. That's mean the control is keep on switching in between the is even and is odd function. And look at the line, if x equal to 0. This is what we call the base condition. In case of indirect recursion, any one of the two functions must have the base condition. Otherwise, the process will become infinite. That's mean you have to write the base condition either within the is even function or within the is odd function. The choice is yours. Let's start with the state diagram. At the left hand side, I place the program for our reference. Here the program contains two functions, is even and the is odd function. Both are accepting a single parameter. From within the main code, is odd function is called with the parameter 3. Now look, at the right hand side, from main we are calling is odd with the value 3. So you can think like this. That's mean is odd is called with the parameter 3. within the body of the is odd function there is a single line, return not is even within bracket x. Look, I have written return not is even within bracket x. Here x is 3. Now from this point of code, it is calling is even function. That's mean from within the is odd function, is even is called. So the control will move to the is even function. So you can think the next state as like this, is even within bracket 3. Here x is not equal to 0. So that's mean the else part will execute. Within the else part, return is odd function is called with x minus 1. So return is odd function is written over here, and x minus 1 is, here x is 3, so 3 minus 1 is 2. Now since is odd function is called, so again from the is even function the control will again move back to the is odd function. So look at the scenario. So is odd function is called, and now this time the value of x is 2, because from the previous state it sends the value 2. And here is a single line, return not is even, so I have written return not is even, and the parameter is 2. Again the control will again move back to the is even function. This time also the value of x is not 0, so the else part will execute. So I have written return is odd x minus 1. This time the value of x is 2, so 2 minus 1 is 1. Now again is odd function will be called with the value 1. So look at the next state, is odd with the value 1. Here return not is even, the value will be remain in the same state or in the same value, that is 1. So again is even function is called. Then look what happens in the is even function. This time also x is not equal to 0. Here the x is 1. So that's why the else part will execute. So return is odd x minus 1. That's mean 1 minus 1 is 0. So again the is odd function. This time the parameter value is 0. It will execute the same line, return not is even within bracket 0. Again the control will move to the is even function. This time the value of x is 0. Look, the previous stage the value is 0, so this 0 will be passed to the next state, that is even function. And now the x is equal to 0. So what it will do, it will return true. So whenever within the is even function, if it encounters x equal to 0, it will return true. So this time it will return true. So from this point of the code, this true will be returned back to the previous state. That's mean this true will be returned back over here. So you can think like this, that is even within bracket 0 in the previous state will be replaced by true. And this state will now return not of true. Not of true means false. So false will be returned back to the previous state. So this will be replaced by false. In this state only false will be returned back to the previous state. So where it will return? It will return to the previous state. It will return the false to the previous state from where it has been called, that is from over here. So this false is accompanied with this not. So not of false means true. So true will be returned back to the previous state. So this will be replaced by true. Again, it is simply written true. So true will be written over here. So true will replace the is even within bracket 2. Now not true. Again, there will be a false. This false will be written back to the previous state over here. This time also only false will be written. False will replace is even within bracket 3 in this state. Now not false. Not false means true. So within the main function from where it has started, this will be replaced by true. So now check whether 3 is odd or not. Yes, it is returning true. That's mean 3 is odd. The condition is true. You can try the same procedure by placing 4 in place of 3. And then you will finally get false over here. That is within the main code. But look one thing, indirect recursion generates too many states within the memory. I will suggest you to do the same program without using indirect recursion. That's mean if you solve this problem using direct recursion, you will find that the number of states generated using direct recursion is comparatively much less than the indirect recursion. So this is all for this video. Still, if you have any problem, write it down in the comment box. I will try to reply you back as soon as possible. Thank you.